Here is our next inequality. And yes, there's going to be some trickery on getting it to match. The right-hand side's greater. And again, what we use is used for our target once we get to our show. But what I'm showing you right now is obviously the problem is proof that n2 to the n is less than n factorial for every integer greater than 4. So this is very different too. And that's actually going to show up underneath as well. So just heads up on that part. But anyway, so in our base case that I'm showing you right now and in our induction hypothesis, everything is pretty good to go here. And then we get to our must show that we are going to have our k plus 1 involved. But notice again, I'm going to be starting off with what was originally given, which is our inductive hypothesis, and we're going to build from that in order to get our inequality done. So you'll notice, and forgive me, I know a lot of things are showing up here, but I got to be involved on this one, or be in it here, is that first we're going to focus on the left-hand side. So the left-hand side for my 2k needs to look like 2k plus 1, and we just did that. So what I'm going to do is I'm going to multiply the 2k times 2 to the 1 power, and I'm going to do the same thing on the other side, and that gets our 2k plus 1. Now, as long as it's equal on both sides, and hey, that's just fine, because we already know this is less than the other side because we just did our base case of this. So we're good to go when it comes to that part. So the left-hand side matches. We need the right-hand side to be k plus 1. So that 2 to the 1 is a problem. So we're going to have to work with that in order to get our k plus 1. Now, remember, I got a target here that I'm looking for, which is a k plus 1. So since k plus 1 is greater than 2, and that's our base case help that we just did, we can replace that 2 with k plus 1. Now notice that k plus 1 did not come from the atoms. We needed the k plus 1 in order to do this. So that's what's going to preserve our inequality, and it's going to make our lives a little bit easier here. So what we end up having is notice the left-hand side didn't change at all, is less than, I moved that 2, which was originally here. Now it's k plus 1 to k factorial. Now with some trickery here too on our factorial property, which by the way, you're welcome to pause and kind of go through this here, but I'll still go through it here in a moment. I can go ahead and say that's k plus 1 factorial. Now why? And that matches what we want to show. Why was that? Because think about it, the k plus 1k factorial, this is how we would write it out if we were frankly doing all the multiplication. It's k plus 1, then k minus 1, and it keeps going down, right? Like 4 factorial is in 4 times 3 times 2 times 1. Well, we did k plus 1, k minus 1. Notice there's nothing unbroken in that sequence. So once I added that k plus 1, that superseded the k, and that really now equals k plus 1 factorial. So a little bit of shenanigans in order to get exactly what I wanted. And again, I told you the factorial property is going to come into play on this, and it did right at the last second. So that's what helps us get into place. Notice I had to match the left-hand side first, then I went ahead and get the right-hand side and go from there. And again, I'm not pulling things from the sky here. I know I needed k plus 1. We had k plus 1 already in our base case. That's what helped us solve this out and go from there. The k plus 1 I also go over in here as well. So if there's anything that you have any reservations about, while it seems random, if we had our k has to be greater than 4, then we know then our k is going to be greater than the 2. In no case, because again, 4 plus 1 is greater than 2, so that's 5 greater than 2. So we knew that's going to happen, that we can get away with that. So I just wanted to make sure you understand that part too. There is a lot of trickery in this, and that's why I'm on these types. Wait till we get to division.